Okay, in this video I am going to continue primal dual relationship, which already have started, and you already have seen part 1, part 2 and part 3. Now this is going to discuss part 4. Under part 4 I am going to discuss one minimization types of LPP, linear programming problem. So objective functions have given in the form of minimization form, and there are some numbers of constants. So if you go back and see part 3, you will find there are in that part also have taken these types of example, and the procedure, whatever the procedure have applied there, I am going to apply the same procedure, and you will see what's the difference in between previous and this question. So there's only minor difference. If you compare from part 1, part 2, part 3, part 4, you will see just I have proceeded according to their complexity. In part 1, just I have discussed basic thing. Basic means just relation between the primal and dual, and have written in the tabular form. So just to come to know what are the basic relationship in between primal and dual. Then in part 2 I have taken a basic example with two constants, and both the constants was in the form of the equations, and I proceeded and I introduced how to solve these types of questions, and all the variables was there in the greater than equal to form, greater than equal to 0 form. But if you come to see in part 3, you will find this condition exists. Means they have considered two variables, x1 and x2 was greater than equal to 0, and one variable was unrestricted in sign. But here there is minor difference. One variable is greater than equal to 0, one variable is unrestricted in sign, and one variable is less than equal to 0. So this question is somewhat different from the previous one. So just go from part 1 to part 4, then you will find all the steps, and you will be confident over all the different types of questions. Whatever will come to write the dual of given primal, then you will be confident over any types of question to write the dual of given any LPP. So here is very simple. There is no more steps. Just you need to go for certain steps, then you need to apply the primal dual relationship procedure, and you will get the answer. So what is the basic concept here? Basic concept is very simple here. First thing, just I am going to proceed. So proceed means just need to first copy. I am not going to write its dual now. Just I am going to copy whatever the primal have given, and once I will start to write the dual, then you will see how to change from primal to duals. So now just copy 8x1 5x2 and plus 4x3 subject to 4x1 plus 2x2 plus 8x3, and you know how to change equation to inequalities form. So one you can write in greater than equal to form, and in second you can write 7x1, the same constants you can write twice. So 4x1 plus 2x2 plus 8x3 less than equal to 12. Okay, so these equations have got changed into the form of inequalities. Now here 7x1 plus 5x2 plus 6x3 have given into the form of greater than equal to 9. 8x1 plus 5x2 plus 4x3 have given less than equal to 10, and 3x1 plus 7x2 plus 9 x3 is greater than equal to 7, and whatever the conditions I have written, just I am going to copy now. x1 is greater than equal to 0, x2 is unrestricted in sign, and x3 condition I have given less than equal to 0. So now this is the condition over the variable. So how many constants and how many variables? So now here we can see there are 3 numbers of variable, x1, x2 and x3, and 4 number of constants. It means once this primal will get changed into the form of dual, then numbers of variable will become the number of constants, and number of constants will become the numbers of variable. It means now here there are 3 number of variables, so in dual there must be 3 number of constants, and here 4 number of constants. So in dual there must be there must be 3 numbers of constants. So primal to dual, this is the first condition. Means number of variables will get changed into the number of constants, and number of constants will become into the number of variable. First thing, and the matrix whatever is going to be created by this primal will get changed into the in dual will get the transpose of this matrix. So suppose you are going to consider this matrix as A, so there you will get A transpose. First thing. Second thing, whatever the right hand side of the objective function, this must appear at the coefficient of objective function, and the coefficient of objective function must be appear at the right hand side of the constant. So this is the condition, and at the end this condition must be fulfilled. So whatever the condition, this already have written in the tabular form in part 1. So just to go to see, that is just I think means 17 to 18 minutes of videos. So you can go and see all the videos for this primal dual. Just I have prepared maximum up to 20 minutes. So it is very easy for you to go for different videos to see and try to understand the concept. So it is on the sequence order. It is in the order. If you go to see part 1, then part 2, then part 3, then part 4, then you will come to understand all the concepts from basics to advanced. So now here, so how many number of variables? Number of variables in primal is equal to 3 number of constants in primal is equal to 4. So in dual it will get changed. Okay, so now I am going to proceed. So this one just going to erase because new LPP already have written. So now going to use that LPP to proceed. Now also I am not going to write it dual, just I am going to copy whatever questions I have given. Just I am going to copy first 8x1 5x2 plus 4x3 subject to 4x1 plus 2x2 plus 8x3 greater than equal to 12. So question is already have given into the form of minimization form. So just you try to write the constants in the form of greater than equal to inequalities form. So here in the second I am going to change this inequalities form into the greater than equal to form. So just we need to put sign both the sides, so this sign will get changed. So here I am going to multiply with -1 from at both the sides. So 4x1 minus 2x2 minus 8x3, it will give greater than equal to -12. So this already have got changed. This one already have given into the greater than form. So no need to change. 6x3 greater than equal to 9, 7, 5, 6 greater than equal to 9. This one is less than, so you need to change -8 x1 minus 5 x2 minus 4 x3 greater than equal to -10. You can see here -8 x1 minus 5 x2 minus 4 x3 greater than equal to 10. This one is already in greater than form, so no need to write, no need to change this one in another form. Just need to copy this one is greater than equal to 10. So now already have changed all these inequalities into the form of greater than equal to. Now can proceed. But the conditions here, whatever the conditions over x1, x2, x3 have given, just you need to write here whatever have given, because over the condition now I didn't make any changes over the restrictions, whatever the restrictions have given over the variables. So as per the restrictions we will move into the next step. So just now here I am going to copy x2 is unrestricted in sign and x3 is less than equal to 0. So whatever the condition I have given, now just I have copied and proceeded. In next step we will see what's the changes. Now I am going to make the changes. Here wherever you find x2, suppose here x2 have given into the form of unrestricted form, in unrestricted in sign. It means if you are going to consider this variable with the difference of these two variables, then these restrictions can be removed. So this To remove this restriction, whatever the restrictions I have given over the variables, because at the end we need to find all the variables must be greater than equal to 0. So here only one variables I have given into the form of greater than equal to 0. Rest of two variables is under the certain condition. So first we need to remove these conditions, and then only we can proceed for its duality. Okay. So now I am going to replace, suppose going to consider x2 is equal to, so x2 already variables have been considered up to 3 because there are 3 numbers of variable. So now here we can consider x4 minus x5 because there is a restrictions over the x2 is unrestricted in sign. It means if we are going to consider all the variables as a greater than equal to 0, then we need to subtract these two variables. So this condition is going to be changed into the form of greater than or equal to form. And if you are going to change this x3, because x3 is less than or equal to 0, so I am going to consider x3 is equal to minus x6. So if you are going to change variable with this variable, so all the conditions of the variable will get changed into the form of greater than or equal to 0 form. So now I am going to write here mean z. After getting these changes, we will proceed for the dual forms to change from primal to dual. So we will see how to change. Now I am just copy the terms whatever I have given for x3 subject to for x1. We are going to make the changes in x2. So x2 is appear here. So x2 appear here. So plus 2 x4 minus x5. It means 2x4 minus 2 x5. x2 have got changed, and plus 8x3 it is going to be changed with minus x6. So minus 8 8 6 greater than equal to 12. In this way I am going to change all these constants. So here I have given minus 4x1 minus here negative sign. So minus 2 x4 minus plus 2 x5. So here minus plus 8 6 will give in this form 7x1 plus 5 x4 minus 5 x5. Here at the place of x2 minus 6 8 x6 greater than equal to 9. Okay, minus 8 x1 minus 5 x4 minus plus 5 x5 minus plus 4 x6 greater than equal to minus 10. 3x1 plus 7 x4 minus 7 x5 minus 9 x6 greater than equal to 7. So here all the restrictions whatever I have given over the variables is going to remove now. So x1 x2 already have removed with x4 and x5. So there is no x3. x3 is also have got changed. So x1 x4 x5 x6 will always be greater than equal to 0. So now this is the new LPP. So now we have got the LPPs in its standard form. So whatever the forms initially I have given, now I have got changed into the standard form because all the constants are in the form of greater than equal to form, and objective function is in the form of minimization type. So according to minimization types, now constants, all the constants are in the form of greater than equal to. Now going to write its dual. So to write its dual, minimization will get changed into maximization form. Z will get changed into some suppose Z star. And you know very well the formula, right hand side of the constants will become the coefficient of objective function. So 12. Now going to consider new variable y1 minus 12, y2 plus 9, y3 minus 10, y4 plus 7, y5 plus 7, y5. Okay, so now all the right hand side of the constants have become the coefficient of objective function, and the coefficient of objective function here will become the right hand side of the constants, and sign will get changed. So here the sign is greater than equal to, so how many constants, how many coefficient of variable? There are 3. So we need to write 3 condition, one for 8, second for 5, third for 4. This condition now going to change. So first we need to move for x1. So is there x1 is available in all 4 equations? Yes. x1, 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 x1. Means there are 5 constants and variables. How many variables? 4 variables. But what's our aim? Our aim is to change this one. Means number of constants 3 and numbers of variable will come to change 4. So this condition is not going to fulfill now because number of variables 3, but here numbers of variables is going to be changed in 5 and number of constants here 4, but here number of constants will be 3. So number of variable must be 4 and number of constants must be 3. Just get reverse. But this condition is not going to fulfill. So now we need to proceed for the further process. So now here, because x1 is available in all these 5 constants, so just we need to write like this: 4 subject to 4 by 1 minus 4 by 2 plus 7 by 3 minus 8 by 4 plus 3 by 5. Okay. Now same for x4, because x4s are available in all these equations. So now we'll start from here: 2 by 1 minus 2 by 2 plus 5 by 3 minus 5 by 4 minus 6 by 5. Oh, sorry. 2x1 minus 2 by 1 minus 2 by 2 plus 5 by 3 minus 5 by 4 plus 7 by 5 plus 7 by 5 is here. For second equation, 2 minus 2, 5 minus 5 and 7. For third, so how many variables? There are 4 variables. Oh, so we need to write, okay, oh sorry, in the objective function we didn't make any changes. So here also we need to make changes because we are having 4 variables here. In objective function, because x2 already have got replaced with x4, x5 and x3 have got replaced, but here I forget to replace. Just I am going to replace here itself, then you will see the solution. So now 5, because now I am not going to write this one, I will repeat these constants again. How to write? Objective function is okay because right hand side just have got become the coefficient of objective function just here because there are 5 variables. So now 5 and 4x3. So this will become 8. Now I am going to write here itself, mean z is equal to 8x1. Here I am not going to make any changes. With x2 will become 5 x4 and x5. So 5x4 minus 5 x5, x2 have got replaced and x3 will also get replaced because 4 x6. So now this is the new objective function, because in constants already have made changes but I forget to change the objective function. Now I have got change the objective function. So objective functions mean whatever the right hand side of the constant will become the coefficient of objective function and the coefficient of objective function will come to the right hand side of the constants and sign will get changed. So here greater than equal to, so here sign will get changed in the form of less than equal to. So total 4 coefficient. So we need to make changes in these 4. So what right hand side will come? 8, 5, minus 5 and minus 4. This will come at the right hand side of the constants. And because here in all the equations x1s are available, in all the equation x4s are available, all equation x5, x6, it means just we need to change this column to row form because A is going to change into the form of A transpose. It means 4 now subject to 4 by 1 minus 4 by 2 plus 7 by 3 minus 8 by 4 plus 3 by 5. This one I have got changed in this form. Similarly here you need to start 2 by 1 minus 2 by 2 plus 5 by 3 minus 5 by 4 plus 7 y5. This one I have got changed. Similarly for x5, just you write minus 2 y1 plus 2 y2 minus 5 y3 plus 5 y4 minus 7 y5. Similarly for x6, minus 8 y1 plus 8 y2 minus 6 y3 plus 4 y4 minus 9 y5. Okay, now here, because the number of variables here, how many variables? 1 2 3 4 5. It means variable have got changed, and the constants, there was 5 number of constants, now there are 4 constants, but still this condition is not going to be fulfilled. Condition what? y1 y2 y3 and y4 and y5. 1 2 3 4 5 all must be greater than equal to 0. So this is the new LPP. Now I am going to, then again, because already have written its dual, but in this dual is not going to fulfill the criteria of primal dual relationship. So we need to proceed further. Just copy this one. Maximization type z star is equal to 12 y1 minus 12 y2 plus 9 y3 minus 10 y4 plus 7 y5 plus 7 y5. Okay, so now here it is very simple to see one thing that is very important here. If you are going to take 12 common here, then you will get the result y1 minus y2. If you are going to take 4 common here, y1 minus y2, 2 common, then y1 minus y2, minus 2 common, y1 minus y2, a minus 8 common, y1 minus y2. It means in all the equations and in objective functions, these two terms are going to give you some common terms. It means here, now what is the condition here? Then again we need to assume, let y1 minus y2 is equal to, up to y5 already have considered, so here we can consider y6. Okay, so y1 minus y2 we may consider y6. Once if you are going to consider y6, means just to go back and remember, in the question have given the form x2 is unrestricted in sign. x2 was in unrestricted in sign. Okay, so we replaced x2 with x4 minus x5 because x2 was in unrestricted in sign. So now, because here the same we are going to do the reverse term. First we have replaced x2 with x4 minus x5. Now I am going to replace y1 minus y2 with y6. It means just we are going to give the reverse functionality. It means here the condition over the y6. So here you will find y6 is unrestricted in sign. You will get here y6 is unrestricted in sign, first condition. And next we'll see, is there any other replacement is there. Okay, so now just see here, and y3 y4 y5, rest of 3 more variables will be here. So now here we can write 12 y1 minus y2 can be replaced as a 12 y1 minus y2 will consider as a y6. So 12 y6. Okay, now and any other changes? No, any other changes. Now I am going to write the new constants. For y1 minus y2 is y6 plus 7 y3 minus 8 y4 plus 3 y5 less than equal to 8. 2 y6 plus 5 y3 minus 5 y4 plus 7 y5 less than equal to 5. Here minus 2 y6 minus 5 y3 plus 5 y4 minus 7 y5 less than equal to minus 5 minus 8 y6 here minus 6 y3 plus 4 y4 minus 9 y5 less than equal to minus 4. But here how many variables? y6 y3 y4 and y5. These 4 variables must be greater than equal to 0. So now from 5 variables, 2 variables have got replaced in 4 variables. So now variables conditions is going to satisfy because constraints are 4, it means variable must be 4. So now variables condition have got satisfied. But here the number of constraints must be 3, but here number of constraints are 4. So these conditions, how these conditions is going to be satisfied, so we will see here. But rest of variables x1 there, sorry, no, x, y, y6 already have written, y3 y4 and y5 must be greater than equal to 0. So restrictions over y6 is unrestricted in sign. So that already have got. How I am going to change? So now you can see here. Okay, next already have written this new form. So now I am going to write it again. Then you will see how the primals is going to change into the form of dual. So very simple ideas, very simple concept. Just you need to proceed step by step. Then at the end you will get its dual form. But dual must fulfill the condition. Z star is equal to 12y6 plus 9 y3 minus 10 y4 plus 7 y5. Okay, here just you see very important thing, just you need to concentrate over this important part. If you come to see these two equations, then you will find these two equations is nothing. These two equations is going to show you that is these two is not in inequalities form. If you change these two inequalities into the equation, it will change into the single form of equation, because if in the question itself you have replaced equation to inequalities form by applying this formula. So here just you see plus minus plus minus minus plus plus minus plus minus. It means all the coefficients are same, all the variables are same, right hand side of the constants are same. It means these two constants are going to give you the equation. So first one just copy, subject to 4 y6 plus 7 y3 minus 8 y4 plus 3 y5 less than equal to 8. These two will give you equation. It means 2 y6 plus 5 y3 plus 5 y3, okay, plus 5, because this form for maximization less than equal to I am going to consider. So this one will get changed into the greater than equal to, but we are going to consider as the equation. So 2y6 plus 5y3 minus 5y4 plus 7y5 is equal to 5. Now these two constants have got changed into the form of equation. Last one just need to copy 8y6 minus 6y3 plus 4y4 minus 9y5 less than equal to minus 4. Okay, now then what is the condition now? Condition is same, y3 y4 y5 must be greater than equal to 0 now as per the condition now, and y6 is unrestricted in sign, unrestricted in sign. Okay, now see what is the next step. Next step is very simple, just you need to proceed. Just check how many variables, 3. How many constants, 3. It means in its dual number of variable must be 4. So now there are 4 variable, condition satisfied. Variable 3, number of constants must be 3, number of constants 3, condition got satisfied. But the second conditions, if you go to see the primal form, means whatever the matrix, whatever the A matrix is going to be created by the primal in the dual. That matrix should change into the form of A transpose. So but here if you go to check, you will not get now A transpose. So where you are going to see the changes, just to copy same question, max Z star is equal to 12 by 6 plus 9 by 3 minus 10 by 4 plus 7 by 5. Okay, now here subject to 4 by 6 plus 7 by 3 minus 8 by 4 plus 3 by 5 less than equal to 8. 2 by 6 plus 5 by 3 minus 5 by 4 plus 7 by 5 is equal to 5. But here you will see at the right hand side you are getting negative sign, so just you need to replace with its positive. So you need to multiply both side by -1. So you will get 8 by 6 plus 6 by 3 minus 4 by 4 plus 9 by 5 greater than equal to 4. So this sign will get changed and all the sign of the respective coefficient will get changed. Okay, but here what's the new things you are going to get? What's the new you have got here? So we will see now. Here we can say y3, y4, y5 greater than equal to 0 and y6 is unrestricted in sign. Okay, now in next steps we'll see what's the changes need to made over this LPP. So it will give you the matrix from A to A transpose. Then at the end we'll check matrix have got A transpose or not. 12 y6 plus 9 y3. Here just see, because here the coefficient y4, all the sign with this variable y4, now you are going to get negative. It means this y4 is going to show you this y4 now in this form. You can say y4 here, because all the conditions with y4 now negative. It means y4 now is showing less than equal to 0. Means y3 y5 is already greater than equal to 0, but y4 is showing in the form of less than equal to 0. Now sorry, y4 now still y4 is greater than equal to 0. Here I am not going to make the changes. Once if you make the changes, it means where you are going to make the changes, you need to replace this variable to its negative, so this coefficient will become positive. It means now you can write here, let y4 is equal to y7, because up to y6 already have considered. So now you can replace y4 with negative sign minus y7. So here you will get subject to negative will get changed. So 10 y7 plus 7 y5, and now here 4 y6. Step by step, better to move step by step. That's why I am moving very slow, just for the understanding. Plus 8 y7 here plus 3 y5 less than equal to 8. 2 y6 plus 5 y3 minus 5 y4. So y4 have got changed with y7 with negative sign. 5 y7 plus 7 y5 is equal to 5. So these variables have got replaced with negative y7 sign. Now 8 y6 plus 6 y3 plus 4 y7 plus 9 y5 greater than equal to 4. Now here you can see, because y4 have got replaced with y7, so now you can say y7 is less than equal to 0 in this form, and rest of this x 3. Whatever the variable here, x6 means y6 is already restricted, so you have replaced y4, so now you have y3 and y5 greater than equal to 0, y7 less than equal to 0, and y6 is unrestricted in sign. Okay, so now I have written all these variables in this form now, but here number of variables and number of coefficient, these conditions have got fulfilled. It means number of constants must be 3, so number of constants are 3. Okay, number of variables must be 4, it will get changed, so number of variables are 4. Condition have got satisfied, but here just we need to change variables name, so you will find there is some in certain order. So suppose max, just I am going to change this w z star with w here, like z star with w. Are you getting? Is it clear? Okay, y6 with v1, y3 with v2, y7 with v3, y5 with v4, and we'll see the condition. Now max w is equal to 12 v1 plus 9 v2 plus 10 v3 plus 7 v4. Now it will show you in certain order, so you will find the exact relation. 4 subject to 4 v1 plus 7 v2 plus 8 v3 plus 3 v4, 3 v4 less than equal to 8. Okay, are you getting? Just I am going to replace variable with its respective name. 2 v1 plus 5 v2 plus 5 v3 plus 7 v4 is equal to 5. 8 v1 plus 6 v2 plus 4 v3 plus 9 v4 greater than equal to 4. y3 have replaced with v2, y5 have replaced with v4, these two are greater than equal to 0, y7 have replaced with v3 is less than equal to 0, and y6 have got replaced with v1, so v1 is unrestricted in sign. Now here you can see and you can compare with original one, whatever I have given primal, then you can compare with its dual. You will find now you have got the dual, because the condition number of variables 3, it means in its dual, because this is the primal. So number of variables have given 3, so number of variables in its dual will change from constants. So variables have got changed in 4, and number of constants must be 3. So now you can compare here. Number of constants 3, number of variable 4. This condition have got satisfied. And you can also check whatever the questions I have given and whatever the A, matrix A is going to be created, you will get, this is the A transpose, so you will get A transpose here. So you can check from the questions. So I already have erased from the board. So these questions you may just compare all the column 1, column 2, column 3, column 4. You will find these coefficient will be there available in row. First column will become, first row have become first column, like this. Column have got changed into the form of row, and row have got changed into the form of column. So here have got interchange. So A have got become A transpose. So you will see here. What is the important thing here? Very basic and very important thing. Just you need to compare here which variable here is going to show you unrestricted in sign. V1 is going to show you unrestricted in sign. So V1, why V1 is going to show you unrestricted in sign? Because we are going to replace according to the variables, because variations in the variable, difference in the variable. So just you go to compare all these, whatever I have mentioned in table in part 1, just you go to see part 1 and compare all these things. Number of variables have got changed into the number of constants, number of constants have become number of variable, A have become A transpose, okay, and right hand side of the constants become the coefficient of objective function, and the coefficient of objective function have become the right hand side of the constants. So this is very important to compare all these things, then only you can say now you have achieved the dual of given primal. So okay, I think you have understood very well, because I have explained whatever the possibility to explain in a detail. I try to give you all the concepts related to primal dual concepts, and one more thing that's I am going to explain in next video, that is the theorem, different theorems of primal dual. So different theorems we'll take with some examples, and we'll try to prove how these theorems is going to work, and how you can prove these theorems through some certain examples. So it's very easy, just we'll take some examples and prove. So okay, all the best. Thank you very much.